Good afternoon, everyone. Welcome to question 1 of the analytic geometry problem set. We've been asked to find the center of mass of this canopy, and it has a vertex at 0, 0, 10, 0, and 12, and 2, 12. The center of mass would be at the centroid, and so we need to find where that is. What is the centroid, you ask? So here are some pictures of centroids. A centroid is found when we take the median of one side. So you have to find the midpoint, and then you put a line through that midpoint and the opposite vertice. And then that will give you a line that's called a median. And then when you take one more median, they will intersect at the centroid. But another thing that's going on with this centroid, and this is going to be really useful to us to find it, is that this part of the median is twice as long as that part of the median. In other words, this centroid occurs 1/3 of the length of the median from the side, or 2/3 the length of the median from the point. So that way we only need one median to do this. You can do the equation of two lines and find their intersection, or you can remember this neat fact that this is 1/3 the length of a median, and that is 2/3 the length of a median. So let's take a look at a type of question that we might have to solve when we want to solve this. So here is a triangle. It has vertices at 5, 8, 1, 12, and -3, -2. So here those points are. I've labeled them. And I'm already imagining that I could find this median pretty easily, or this midpoint, and then find the 1/3 point along that to find this centroid here. So let's see how we would do that. First thing we're going to need is this point here. Okay, so let's find the median of these 2 points. So the median, we're going to use our median formula, and that's going to be the midpoint formula. So the midpoint going from 112 to 5, 8 is going to be the average of the x and the average of the y. So it's going to be equal to 1 plus 5 divided by 2 as my x value, and 12 plus 8 divided by 2 as my y value. Well, that's just 6 over 2 is 3, and that's just 20 over 2 is 10. Okay, so I found this point there is the point 3, 10. All right, and now let's take a look at this line from -3, -2 to 3, 10. Okay, and that's the median. One of the medians of this triangle goes from -3, -2 to 3, 10. So if I start at -3, -2, and I go to 3, 10, what have I done there? Well, I ran 6, and I rose 12. This is a run of 6 and a rise of 12. Right? And that's just another way of thinking about the trip from there to there. If I go 2/3 towards this point, or I come 1/3 that length from this point, then I will find the centroid. It's a cool property of centroids that makes them a little easier to find. If you don't know that trick, this question is a lot harder. So what can I do to find that 2/3 point? Well, I might draw another triangle on here, and I might say this is the triangle that I'm particularly interested in, and it has this run of 6 and this rise of 12, and I get that just by 10 minus -2 is 12, and 3 minus -3 is 6, and so that's my big triangle. What is this small triangle here? That would be 1/3 of 12 this way, and 1/3 of 6 that way. So this would be a run of -4, and a run of -2, and a rise of -4. Because that would be 4, 4, 4, that would be 12, and 2, 2, 2, that would be 6. So that's like, I can just take these numbers, and I can multiply them by 1/3, and that gives me a run of 2 and a rise of 4. And doing this, run 2, rise 4, from that point 3, well, it's -4, -2, that will give me the centroid. So let's start from that point, 310. Start at 310 and run -2 and rise -4. Okay, So that will give me the point. If I run -2, that's 3 goes to 1. I go 3 goes to 1 there. That's 1. And then the run from 10, so the rise from 10 is -4, so that'll be 1, 6. So there, that's the centroid. Done. Final answer. So this is, so then I would have my therefore statement. Therefore, you would have to say, therefore, the center of mass of this canopy would be such and such. But here, for me, therefore, the centroid of this triangle is the point 1, 6. Done. So that's how you can find the centroid very easily from finding one of the medians and thinking of it as a rise and a run, and just going 1/3 the length of that from the side, and that will do it. So that's how you can go about answering the question number 1 on your problem set. Any questions? Send me an email.